Right, good afternoon, everyone. We've still got a few people coming in. Probably folks are still getting their lunch downstairs, but we'll begin because we have a lot to get through this afternoon. I hope you've all done the pre-reading and the preparation for this session that was included in the meeting invite. We do have a lot to get through today. It's a pretty full agenda. We'll be moving pretty quickly. In order for us to begin, I want to draw your attention to this dashboard. We'll be drawing from this dashboard, but I just need to refresh it, make sure we've got the most current data. It should be ready in, it should be ready in a moment. I mean, I'm sorry about this. I can't really understand why this is taking so long. It should be ready already. The spinner, look at it go. It should have refreshed by now. I wonder what's going on. Have you seen this happen before? Yes. How many of you had this happen to you? That's why you're here, right? I guessed as much. How many of you have felt like this one? Have you had that feeling? Yeah, you felt like her. Have you called someone from Tableau and said, hey, I've built this workbook. It's a fabulous workbook. It does everything that my boss wanted, but it's slow. And so I need you to come and fix Tableau. I need you to make Tableau faster. Have you ever had that conversation? I've had that conversation. What if you could leave today with the knowledge to prevent that from happening? Maybe to fix it if you already have it happening to you, and to prevent it from happening again. Would that be all right? Would that be good? Awesome. We're in the right place then. I was starting to panic earlier on because there's no one here. There was about 400 people registered, but I guess they're all having lunch. My name is Jason. I'm lucky enough to live in Sydney. I live by the beach. I'm a volunteer surf lifesaver. And I've also been lucky enough to be a Tableau employee for just under 5.5 years. And in that time, I've been working with some of Australia's largest companies. And I've seen the good, the bad, and the ugly. And I've had that conversation that I was referring to quite a number of times. Happily, there's a way through the mess, a way through the quagmire. So this is what we're going to be talking about today. And I want to give you that knowledge to take home with you to sort out underperforming dashboards. The material that I'm going to present today is drawn very largely from this document. My former manager, Alan, about 4 or 5 years ago, he brought together a lot of information that was available in the public domain, on the web, in the online help, and in people's heads. A lot of tips and tricks and best practices, what to know, what to avoid, what to do, all of the things that contribute, or potentially can contribute to performance issues with dashboards. Now, I must admit this document is a couple of years out of date now, but nonetheless it is still very valid. And to be honest, over the last 12 months, there hasn't been a lot added to the product that contributes, at least from a design context, to performance. We've added a lot to the product, clearly, in the last year or two, but not a lot of that has actually contributed to design performance. Performance from a design perspective, and that's what we're talking about, is design perspective. There's a lot going on under the covers that you have no influence over. So we want to talk about what you have control over. I encourage you, if you have, how many people have already seen this document? It's nowhere near enough. I want every one of you, when you get a chance, certainly not right now, but when you get a chance, go find this document on our website. You can search on our website for Designing Efficient Workbooks and you'll find it. It's a PDF white paper. You can download it or you can bookmark it, whatever you want. But I really want you to go and do this when you get a chance. You don't have to read it from cover to cover. It'll probably put you to sleep if you do. But at least this is a reference guide for addressing issues that you may encounter. And this session is the roadmap to this reference guide. Because there's a lot of stuff to cover, and we will actually go at a fairly fast pace, if you walk out of here with 3 things in the back of your mind, I'll consider it to be a successful session. And those 3 things are that The design choices that you make when you're building a Tableau workbook have a direct correlation to the performance characteristics of the finished work. That means that the choices you make impact performance in your dashboard. And it is true that you typically cannot doggedly pursue a particular design pattern and say, we'll just get this built, we'll make it pretty, and then we'll address performance, because you generally cannot do that. Performance should be your end in mind. I know that the boss wants a pie chart in the top left-hand corner and all that sort of stuff, but performance needs to be an end in mind. And because there are many things that we'll discuss, and some of them are to do with the particular layout of your dashboard, some of them are to do with the data characteristics that your data sources have, some of them are to do with the way you perform your calculations, the way you write your calculations. There's no one thing that I can tell you that you will be able to apply to every single situation. You're going to have to take all of the things that I talked to you about and apply them or think about them in respect of your particular situation. So there's no one magic or silver bullet. At the end of the session, I hope that you feel comfortable that you'll be able to go back to that white paper and go to that space in the white paper and read more detail about the things that I'm about to talk to you about. As I go forward, I'll use expressions like avoid or minimize or use sparingly. I don't mean, don't do it, don't ever do this. I do mean be mindful of the potential impact of the choices you make. We've built features in the product for a particular reason. They give you specific outcomes. But you need to be mindful of the potential impact that each feature or each practice might have. The key features I've highlighted with the little blue circle with the light bulb in it. So let's begin. So the title of the talk is Designing Efficient Workbooks, and I guess that begs the question, what do we mean by efficient in this context? Well, I think you'd probably agree with me that, number one, we want our dashboards or our workbooks to be fast. We want them to load quickly, or at least have the perception of loading quickly. And whenever we interact with the workbook or the dashboard, we also want it to respond to us in a quick or very timely fashion. No one wants the spinner that we saw there. We also, in addition to that, we want our workbooks to be reasonably flexible. And that is to say, there's little point designing a workbook that answers one question, because that's really just one metric. So our workbooks hopefully have the ability to enable some sort of drilling into or slicing and dicing or exploring other ideas or other questions within the data. So there's a bit of flexibility there that we want to be looking for. And lastly, we want our solutions to be reasonably simple. Not simplistic, but simple. It's one thing to engineer an incredibly sophisticated and complex piece of calculation logic in a workbook to do amazing things. But A, that may negatively impact performance, and B, the next person who needs to come up and pick up your work and maintain it may not understand what on earth you've done. So we need to try and strike a balance between these three dimensions, performance and flexibility and simplicity. So the question is, that workbook that I showed you when we walked in, it was sitting there spinning. Why is my workbook slow? Well, there's lots of reasons, and it turns out that there are lots of places where things can happen, and so you need a bit of a roadmap to understand what's going on, and you need some tools to help you understand where things are happening. So let's just think for a second about what happens when we request a visualization to be rendered from Tableau server. We're sitting in a browser, we've got the Tableau server interface up, and we say, I want to see this workbook, or I want to see this viz. We click on it, we send a request over to the server, we bounce around inside the repository a little bit, we need to be authorized to see the viz. We need to then locate the viz and unload it and unpack it. We need to, depending upon the complexity of the visualization, we need to figure out how we're going to render the thing. We need to look at its dependencies, and obviously a lot of those dependencies are going to involve data. So we probably need to send one or more queries off to one or more data sources. Maybe those data sources, maybe we're grabbing Tableau extracts. So we need to go to the extract engine, grab the extracts out of the file store, load them up into memory, or maybe those data sources are externally hosted. Maybe they're in the cloud somewhere. Maybe they're on your laptop. Maybe they're in the corporate network somewhere, or an Oracle or Teradata, or who knows, whatever else. And those queries need to execute within those data sources. The data that comes back, depending upon the granularity of the queries that we're running, and hopefully we're not running queries that generate millions of rows, the data then has to come back to Tableau server. Some stuff has to happen, and then we need to do what's called compute the model. And this involves all of the things that happen when the data, or after the data comes back into Tableau. Think of things like computing table calcs. We know that those are done inside Tableau on the window of data that is coming back from all those queries. We need to do data blending, we need to do sorting, we need to do various other things, build forecasts, reference lines, and all of those types of things. And then we need to think of how we're actually going to lay out the visualization. Think of a scatter plot along two measure axes, and we've got a lot of data points to render. We need to selectively decide which of those, and we turn labels on. We then need to selectively decide which of those labels to render and which of those to hide in order to give you an uncluttered visualization. So there's a lot of thinking that needs to go on there and mapping things out. And then we need to then send a bootstrap or a payload, if you like, back to the browser. So we package up some data, we package up some JavaScript code, and we send it over to the browser. The browser then renders the visualization. Or, conversely, if we're forced to use server-side rendering, the complexity of the viz turns server-side rendering on, the visualization model will be computed and drawn as a series of image tiles. And those image tiles will then be shipped across to the browser. And you thought Tableau just drew graphs, right? There's a lot of stuff going on. And this is terribly simplified. But those are the major steps that have to happen. So let me ask you a question now. Given that you now are experts on what happens when you request a visualization, where do you think there is an opportunity for there to be a lag or a delay introduced to the process? Shout it out. Running queries, I heard that. What else? Oh, someone said all of it. Every step of the way after you click on show me that visualization. Well, that's kind of depressing, isn't it? Everywhere. Goodness me. So that's why we're here. And the good news is there's a way through all of this. So let's now consider very quickly the tools that you can put in your tool belt to help you uncover where things are going wrong or potentially going wrong. And I think the first tool that everyone should know is the performance recorder. Let me know if you do use the performance recorder. Thank you. The rest of you, you've got to find out where it is, you've got to learn how to use it. This is the first thing you need to use if ever you're worried about the performance of your dashboard or a particular viz. So when you're in Tableau Desktop and you're authoring a visualization, you go to the Help menu, you select Settings and Performance, and you say Start Performance Recording. And you'll notice that absolutely nothing happens. And that can be a little off-putting. And that's because Tableau is just now quietly recording everything that you do and logging everything that you do and everything that happens. Now, good practice is to load an empty Tableau desktop with no workbook in it or anything. Do this, Help, Settings and Performance, Start Performance Recording, and then connect to your data, build your queries, build your visualizations, or load an existing workbook. Open it up from disk or download it from Tableau Server, whatever you need to do. So good practice is to start with an empty, turn on the performance recorder, and then do your stuff. Work with your dashboard, interact with it, cause dashboard actions, filter, make selections, do what you would normally do. And then, at the end of that, you go back to the Help menu, Settings and Performance, and you select Stop Performance Recording. And at that point, you'll see that there'll be a slight lag, the desktop will chug away for a few moments, and a new workbook will open up. And it will look like this. It'll be in three main parts. The first chart at the top there will be a Gantt-like representation of all of the events that occur along a time scale. There's a filter up there too. You can filter out, you can sort of look at events that take more than 50 milliseconds or something like that. You might not want every single event because, trust me, there are tens of thousands of them. It'll log absolutely everything that Tableau does. So maybe you set that filter to be just the things that are taking more than 50 milliseconds, something like that. The chart in the middle is then a ranked bar chart of all of the events by time. And there are different types of events. Clearly you can see that there are like executing query, but there are also things like opening up the workbook. There are things like computing geoencoding data, rendering the query, all sorts of events. Some of them will take longer than others. So you might find right away that you have one or two query events that take heaps and heaps of time. Or maybe you find that all of your queries are running really fast, but there's just a lot of rendering activity going on, in which case it's not really the database query that are taking time, it's more related to the complexity of your workbook. So you can get an idea of where the potential problem might exist. The last part of that dashboard right down the bottom there, if you select a query bar in the middle, you can actually see the text of the query that is being sent back to the data source. So if that is where the problem is, you can then go and analyze that query code and see if that's where the bottleneck is. You can also generate a performance recording from Tableau Server. Now, as a server site admin, you'll need to turn on workbook performance metrics in the server settings. But then as a user, as a consumer of a visualization, you can get the URL of your visualization and then add to the end of the URL the suffix question mark colon record performance equals yes. Hit enter, send that request off to the viz, off to Tableau Server, and the visualization will load, and you'll see that there'll be a little clock, a watch with the word performance on the toolbar in Tableau Server, and you can click on that and download the performance recording workbook and open it up inside Tableau Desktop. So both Tableau Desktop and Tableau Server, you can generate a performance recording. Going deeper, and this is for the geeks amongst us, the Tableau Desktop log files are an amazing source of information because they log everything that happens. So you can open up these log files in any notepad, text browser, but they are JSON formats, so they can be really long strings. And your typical notepad or Sublime text is a good one because you can tell it to read it in JSON format text and so forth. Or you can use the Tableau, you can actually, because they are JSON files, you can just dump them into Tableau Desktop. You can select the schemas that you're interested in. I tend to just select all of them. Now, the schemas are a little bit complex. Once you get your head around them, you can then start writing queries in Tableau to visualize all of the events that are happening. The log files are just JSON text, so you can dump them into Tableau Desktop. Or you can go to Git and download the Tableau Log Viewer and just open up the logs from desktop in the Tableau Log Viewer. And the Log Viewer allows you to visualize the queries, to see every event that's going on. So you can search for particular queries, you can search for text, you can look for events, you can search for warning messages, error messages, and basically just go for your life. Very handy tool off GitHub. Talking about log files, the log files are also available on Tableau Server. Now these are massive, and they're also very complex, and they're distributed right across the Tableau Server infrastructure. So happily, from the new TSM interface, you can tell Tableau to generate a snapshot archive of all of the log files. So it zips them all up, compresses them, packages them into one file, and that you can have access to the log files from Tableau Server. Now, this is useful more from the point of view of looking at everything that's going on in Server, and you might be looking for a number of workbooks that might be causing problems. Maybe the issue is every now and then performance on Tableau Server starts to drop, and you have a sneaking suspicion it's because of that one workbook that guy Jason built and refreshes every Monday morning. So you can grab the log files and you can dump them into a utility called Logshark, which is also available on Git, and you can then start to look at performance from a more holistic point of view. So this is less to do with you as an author of a viz and more to do with, I want to find out why my server is performing badly. And you might see that particular workbooks are loading really poorly, maybe at certain times of the day or the week. Also, if you're a site admin on Tableau Server, you can get to the built-in server admin views. And there are two in particular, the stats for load times and the performance of views visualizations. And they will help you, once again, get an idea of what's going on across the server. Here, for example, we see that the overall times for all views There's a lot of visualizations that are loading within, less than about 3 seconds. That's all of the green there, and that's pretty good. But there are some vises that are starting to load in the sort of 3 to 5 and the 5 to 10 second range, which is starting to get a bit uncomfortable. And once again, you can identify the worst offending views from the bar chart down the bottom there. Now, if you really want to roll your sleeves up and get your geek on, you can, in the browser, you can hit F12 in just about every one of the browsers and open up a console. And in the console, you can look at the network traffic between the browser and the hosts. And you might see, looking at the network timeline, you see a gazillion events, and the blue bar chart on the side there is showing you the duration of all of the events that are happening. And you might see one that's really long when you compare it to all the others. And that's probably the bootstrap. That's sending the data and the JavaScript code that's required to render the visualization being sent from the server to the browser. Now, this could be an issue if you're using a lot of mobile dashboards and you're seeing that performance on the mobile is worse than on the browser on the desktop. And it could be that you're using a 4G network and the bootstrap is just taking too long to get across to Tableau mobile client. So you might need to address that. Network traces like Fiddler, there's a bunch of these things. If you really need to get down to the packet level, most people don't need to do this, but occasionally you might have an authentication problem, and you can investigate these like this. There's Tabmon. Like these things, they just keep coming. Again, this is from a more holistic perspective, monitoring the performance of your entire Tableau server cluster. This is an open source tool that's been around for a number of years. Obviously, we've just released the server resource monitoring tool, which sort of supersedes Tabmon. And here we can see what's going on right across the browser, the server, across all of the nodes. We can even manage multiple servers, and we can see, once again, what's going on in terms of performance. So to recap, in terms of the tools that you've got at your disposal, the performance recorder, both on desktop and server, the log files, both on desktop and server, you can analyze them in various different ways. Tools like Logshark, Tabmon, the server admin views, and various other tools as well, and including the new server resource monitoring tool. I see a lot of people taking photos. The session is being recorded, so you'll be able to see this later on. So because there's a lot to look at, many things to think about, I want to present you with a nice handy framework to use to think about how to address or how to research what's going on. And that is a simple framework in 4 steps. And think about things in terms of the presentation layer, which is the visualization itself, how you build your visualization. Then there's the analytics layer, which is more concerned with how you write computations and calculations and how you access the data that you're using in your visualization. The data itself, where the data is hosted, how it is structured, and so forth, and then the platform layer. And I've used this inverted triangle representation intentionally because it represents both the frequency with which issues can occur, so the more often and more frequent at the top of this pyramid, but happily also gives me an indication of the greatest level of changeability or control. So I've got more control over how I build my visualization than I do over the infrastructure on which Tableau Server is running. Right? I can redesign my visualization. I probably cannot add another node and another 64 gigabytes of RAM to Tableau Server. So that's why I've used this. And correspondingly, I'll spend more time at the top and less time at the end. We'll accelerate towards the end. All right, so let's concentrate firstly on the presentation layer, which deals with worksheets and dashboards. So those are the 2 principal elements that we need to concern ourselves with. Less so story points, because story points are just an aggregation of dashboards and worksheets. So our worksheets, so here's a beautiful looking worksheet. I think this was originally put on Tableau Public by Andy Kriebel. And it's a reimagining of a P&L statement. Why might I potentially have problems with this sort of dashboard? It's beautiful. Does anyone have any thoughts? No? Well, we'll get to it. Calculations, yeah, it might be due to the fact that it's made up of many sheets. And we'll get to that. So let's have a look at dashboards. Dashboards, of course, are probably the principal area that we're going to be working with, made up of multiple zones. Now, zones is my sort of terminology. It's not necessarily Tableau terminology. But our zones can be either data-driven or non-data-driven, if you think about it. Non-data-driven might be text that you put on your dashboard, blank spaces, maybe image files, maybe a URL to a web page or something like that, but they're not necessarily driven by the data that is the heart of the dashboard. And then the worksheets themselves are driven by data. So it's probably the worksheets that consume most of our thinking when it comes to this subject. Worksheets, of course, are made up of headers and axes, panes, titles and captions, field labels, legends, and then marks. Are you familiar with the term a mark? Yeah? Cool. A mark represents the intersection of a row and a column in the data set that comes back. You think about a projection in SQL where we're getting rows and we're grouping by columns and so forth. Oh, in this particular example, with these stacked bar charts, it's important to recognize that each segment in the stacks is a mark. So the more segments you have in each bar, the more marks you have on the page, for example. So first tip of the day is the simpler your worksheet, the faster it will be. The more complex your worksheet, in terms of the number of marks, the potential for it to be slow increases. Now, when you're looking at Tableau Desktop and you look right down to the bottom left-hand corner on the status bar, it gives you an idea of the number of rows and columns of data that have come back to Tableau, and it tells you the number of marks that are on that particular worksheet. So keep your eye on that particular number. The smaller the number, the better it's going to be in terms of performance. This one says 78,624 marks and 19,656 rows, which is not a great place for a dashboard to start. And you might recognize that that's the one that I showed you when we walked in. If I adopt a different visualization metaphor, and rather than just vomiting data onto a page and putting lots of filters on it, I use another technique that is more visual. Look at the number down the bottom of the page now, 130 marks, and only a few rows and columns. So I'm aggregating data to view in my dashboard, as opposed to just dumping every row in the database on a page. So keeping the number of marks to a minimum is going to help you on your journey. Also be aware that not every mark type is the same. The inbuilt marks, bars, lines, circles, shapes, they're all very optimized. They render very quickly. And of course, we can manufacture marks. We can build polygons, such as the arc segments in this beautiful dashboard. But every one of these manufactured polygons requires us to draw a series of points along a curve. And we know from school mathematics that a curve is nothing more than a series of points. The smoother the curve, the more the number of the points. So something like this probably requires us to implement some sort of data densification or scaffolding trick in order to draw nice, smooth circle arc lines. So the more work we do in creating polygons, the more work Tableau has to do in rendering those marks. Now, whilst it's optimized, the more complex the mark type and the more of them, the more work we have to do, and work requires time. Similarly with maps, needlessly rendering polygons on a map and then just putting a single metric on color might not give you the best answer to your question. The answer to every geospatial question might not be a map. Maybe if you're just looking for the greatest or the highest amount of sales by postcode, the easiest thing to do is just draw a bar chart and sort it by the value of sales. It might not be as easy to find the top 5 if you put them on a map, but maps take longer to render than other types of mark. Now, we do want our dashboards to be beautifully interactive, don't we? We want people to interact with our dashboards, but we need to remember that every interaction also takes time. If we trigger actions, if we trigger URLs, all of these types of things we can do in a dashboard, they all take time. And the more such activities, the more time is going to be taken. I'm going to talk about, I missed a point on that last slide, but let me go back. You notice there's a filter down on the bottom right-hand side here, and it's an enumerated filter, meaning that we list out the value of the domain of that particular dimension in the filter. I had a customer in Sydney who just absolutely thought it was important and necessary to put customer name on a drop-down filter. Problem was they were a telecommunications company. How many customers do you think they had? A lot. Tens of thousands, no matter how you sliced the data up. And so they were confused and unhappy because it took a long time for the filters to render. So just be aware that if you need to filter by a dimension that has a very high cardinality, I would suggest that an enumerated filter is probably not the best way to go. It's probably better to consider using a wildcard match in your filter. So that way we send the wildcard expression to the data source, which evaluates that expression and returns a subset of the domain of values back to the filter. So that way we're not rendering the entire 20 million rows in our filter. We're only rendering maybe a few hundred at most. So every part of the dashboard that contains a visualization potentially drives one or more queries. So looking at this dashboard, that's the example I showed you a couple of slides ago. It's for every metric, sales, discounts, cost of goods sold, operating expenses, and so forth. For every one of those metrics, there are two charts. There is a bullet chart with a reference line, and there's a spark line. So in this case, if there's 9 metrics, there's 18 visualizations. And it's the design of this particular dashboard that causes me to build 18 of those charts and then put them all together onto a dashboard. I could have achieved a similar outcome by just displaying 2 charts. One, a bullet chart, and then maybe sort it by KPI. And underneath that, maybe a spark line and break it out by KPI. But because we want the bullet chart and the spark line grouped together for every KPI, I have to split it up like this. And so each one of those charts causes a query to fire to go back to the data source. So if I was to look at a performance recording of this, I'd probably see 20 or 23 or 24 queries going back to the data source. Here's this thinking about large enumerated filters again. I think I already covered this. Large high-resolution images. Sometimes you want to embellish your dashboard with a beautiful image from the web or a beautiful high-resolution image. Just think about the time required for that to come back across to the client when you're driving your dashboard. How many of you know about global filters? You know when you say, apply this filter to all dashboards from this data source or all worksheets from this data source? It's great, isn't it? It's convenient. You're able to filter all of those worksheets using the one filter. But just be thinking about the impact of that in terms of the number of queries that might have to fire. Looking at this same dashboard again with those 18 particular worksheets, there's also 3 filters here, and they happen to be chained together. We've got region and channel and product. So whenever I click on one of those filters, the other 2 filters need to change in order to reflect the selection. But just think about what might happen. If I select one value from one of those filters, I might then have to fire off 19, 20, 21, 22 filters back to the data source. So just be mindful of the use of filters, global filters or filters that apply to a lot of dashboards, a lot of worksheets within the dashboards. Show relevant values, and I'll cover show relevant values pretty soon. The easiest thing you can do to help Tableau Server to be really effective in terms of its use of caching is to set your dashboards and stories to be a fixed size. I know it's lovely to be able to use a variable size, so your dashboard resizes to fill up whatever the browser size might be. But if we're all using the same visualization and my browser size is just 1 pixel different to your browser size, then I cannot reuse the model cache. And so I'm going to have to go and reevaluate the whole model just for myself. And if you've got thousands of people and everyone's using different window sizes in their browsers, then you're potentially disabling Tableau's caching capability there, and you're causing more work to be done. So pro tip, just fix the size of your dashboards and windows if you're distributing these dashboards on Tableau Server. Tableau does a lot of work behind the scenes to try and reuse work that it's already done. I won't turn this into a caching class because we would need another hour at least, but there's caching that goes on in your browser, there's caching that goes on Tableau Server in the VizQL session, so each one of us has a VizQL session. VizQL server tries to reuse those sessions amongst each of us if possible. There's the model cache, there's the tile cache if we're using server-side rendering, the query cache itself, there's abstract queries, the absolute query, and then there's the query result cache. And if we're looking at a distributed architecture, we have a distributed cache that gets synchronized as well. So Tableau tries its very, very best to not have to reach down through the stack back to the database every time we do anything. But this is not a level on caching, but I just say that a lot happens. There's also a lot happening in terms of query optimization. We do a lot of work around query optimization to try and reuse queries that have already been done. Abstracting queries, bringing together queries. We might ask sales by state and sales by city, but we could reuse, maybe we don't need sales by state. We could actually add all of the sales by city up to give me sales by state. So Tableau does a lot of smart things there. So the idea and why I'm showing you this is that we try not to work against Tableau Server's caching mechanism. Some of the choices that you make can cause caching to be invalidated. So I said right at the outset that dashboard design is probably the one thing, or the most impactful thing when it comes to performance of your dashboard. It's also the easiest thing to change. Let me show you a little example. So because I can't talk, chew gum, and show a demonstration at the same time, I've chosen to record this. Look at this. This is a typical sort of dashboard. There's basically a list of data, and then we've got lots of filters. So we pick a country, all of the filters have to be reevaluated. We pick a state, the filters have to be reevaluated. We pick a city, the filters have to be reevaluated. You can see how everything blanks out and then redraws. It's not a particularly graceful end-user experience. We get down and we find a particular subcategory, then we can go and maybe grab a timeline, and we can do something with this data. Apart from it not being very pretty, it's also incredibly ineffective. If I was to run that through the performance recorder, I'd find that it would run, if I took all of the queries that were evaluated to repopulate the filters, draw all the results over and over again, there were 203 queries run just to do that one analysis in that dashboard for a total time, query time of almost 20 seconds. Let me show you, by comparison, another example in which rather than using quick filters and lists, we use views to filter data, and we drill from one level to the next. So we select a country, then we select a city or a state, then we select a city. Within the city, we then might select a particular manufacturer. We pick Fabricum. I see that camcorders are a huge outlier there. I've got context, and then maybe I use a tooltip link to go to another page in that dashboard to show me a timeline of the performance from which I can then lasso the 3 months that I'm interested in, and finally filter the data. So it's a more visually interesting approach, and it also runs in a lot less time, with only 28 queries and only 3.6 seconds of query time. So that's a much more efficient design and a much more visually appealing design. It also gives us the benefit of having context every step of the way. Now, you might have noticed as we were running that little video that at each step, the rest of the dashboard remained blank until such time as I made a selection. And this is a little trick that you can use to delay the loading of data in views until it's necessary. And to do that, the technique that I use to do that video is I just use, when I'm creating my dashboard actions, so I click on the little selection, clearing the selection will exclude all values, rather than, most people just use it to be show all values, which is everything. When you think about a data source with 24 billion rows in it, I don't really want to be displaying all values. So I tend to use this trick where I exclude values until I've made a selection higher up in the tree. It's a very easy thing to do, and I think you all should know how to do that. The other little trick that we've just added, earlier on in the year we added the show hide dashboard container. So you could take a floating layout container, place it on your visualization, and you could enable show hide. Then you can place a view inside that dashboard container. And now with 2019.4, we've added a feature to delay the loading of a view that is inside a show hide container. So if the container is hidden when the dashboard loads, we're not actually loading the data into that view until such time as we expose that container. Then the view will load. So that's another little performance trick that I think you can take advantage of. So to recap, there's a lot here. Keeping your worksheet simple, the number of marks simple, thinking about the types of marks that you're using, minimizing the number of parts to your dashboard, minimizing the complexity of each of those parts, minimizing the amount of interactivity, fixing your size of dashboards, using a more guided analysis framework rather than just vomiting data onto a page with lots of quick filters, and then using those tips to delay loading of data until you absolutely need it, and to refine the amount of data that you want to load in each view. So let's quickly run through analytics. So this is where we're concerned with the data elements that are in our dashboard, the filters that we might be using, calculations that we write, and potentially working across multiple data sources. You might be aware that when we're building our data model, a connection to the data, one of the things that we can do is we can tell Tableau to reinterpret a particular field from one data type to another. A great example that I see all of the time is people often store dates as character strings. But in order to do analysis, we want dates to be dates. So we can recast the data type for a particular field using a little submenu here. But what that causes to happen is a statement to convert the data type from one to another every time I touch that field. Every time I use that field in a visualization, I'm sending a convert or a cast statement back to the data source, which, depending upon the number of such fields and the amount of data, could be relatively expensive and could cause delays in the performance of the queries that are being evaluated. So if possible, we go back to the data and type the data appropriately for analytical needs, if you've got access to the data source. You might be aware of the fact that we have this thing called an order of operations. I see people taking photos of this. This is available in the online help. You can Google it, Tableau's order of operations. It's a good thing to know because it'll help you. I'll just say it'll help you. But just be aware that filters evaluate at different points along that query pipeline, which means that some filters will be evaluated and pushed back to the data source, and some filters will be evaluated inside Tableau. And careless use of these or inappropriate use of these might cause delays in the performance of your dashboard. So if I were you, I would spend some time understanding Tableau's order of operations. You're going to need it anyway if you're doing things like top-end filtering and then you're filtering by state or by city or by country, because you'll want to be able to move your filter up and down the tree to ensure you get the correct results. So I talk about context filters. If I want to move the evaluation sequence of a dimension filter to occur before a measure filter, for example, I would move the dimension filter to context. Now, I've been with Tableau for a while, and for early on days, maybe version 6, maybe version 7, Tableau filters were, the context filters were kind of, they were often evaluated as temporary tables, which meant that when you moved a filter onto context, you had to build a temporary table in the database, which obviously took time. And then if you changed your context filter, we'd need to drop the table and rebuild it, which would all be an expensive operation. The good news is these days, the context filters are evaluated almost exclusively as nested subqueries, so there's no issue there. And you're going to need them with a top-end calculation anyway. But I would say, try not to make context filters interactive if you can get away with it, just because it still adds more complexity to the queries that you're sending back to your data source. You'd be aware that there are different types of filters. There are enumerated filters versus non-enumerated filters, range filters versus discrete value filters, aggregate filters versus row-level filters. Depending upon the dimensions and the measures that you're putting on the filter shelf, you'll get different types of filter functionality. Why is this important? Let me show you a little example. Here is a map of my home country, and I've just covered it in dots. And for the sake of my analysis, I want to select and keep only the brown dots in Western Australia. There's multiple ways I could do this. The first thing I could do would be to grab my mouse, lasso all of those brown dots, and say, keep only. That would result in a large enumerated list with some of them selected. And you may not be able to read the text, but here it says I've selected 5,980 out of 57,522 values. So that's going to send a where in very large list back to SQL Server or Oracle or Teradata or whatever. which may or may not be an effective evaluation. The query optimizer might gag at that and say, this is terrible, and it'll run a really slow query. An alternative way of doing this might be to grab a measure, and just for argument's sake, we could say perhaps longitude, and I could say where longitude is greater than this value and less than this value, and I could range in using a numeric value. And that's going to cause a much more efficient query to be sent back to the query optimizer. I don't know that this is particularly useful, but at least it results in an optimal query. Perhaps more optimally would be to introduce a slicing filter, where even though I don't have state on the view, I could just say, put state onto the filter shelf, and that says, select all of this stuff where state equals Western Australia. And given that that column is indexed appropriately in the database, this is going to be a very optimal query. So the same results achieved 3 different ways. So just think about the type of filter you're going to use when you're building your visualization, because you may get different performance characteristics for each. How many of you use show relevant values? Do you use it a lot? Nodding heads. Yeah, we love show relevant values. We show relevant values to build cascading filters, don't we, in dimensional hierarchies. They're great. Trouble is, they can cause inefficiencies, particularly if we're working across a snowflake schema or a star schema. There are times when using show relevant values, maybe one level of my hierarchy is in one dimension table and another level of my hierarchy is in another dimension table which traverses the fact table using the joins in the data model. If I use show relevant values, it tends to nullify my use of join culling, which then results in all the joins being used in the query as opposed to only the joins that I want. And in fact, I don't even want to use joins. I just want to grab the data from a dimension table to show them in a filter. But show relevant values can be inefficient. Fortunately, it has alternatives which have been introduced in the last year or so. All values in hierarchy, all values in context, and the hybrid hierarchy in context. These are much more efficient when we're talking about dimensional hierarchies. So when you if you've built a hierarchy out of dimensions in your data model, and you place those dimensions on the filter shelf, it will automatically select all values in hierarchy, and it's just more optimally designed. It works better. So I would consider using that as well. Another little trick, I've just gone too far. Another little trick is to actually design small tables that are just the domain of values you want in your filters and drive your filter from those other data sources. And then we can use apply filter to all related data source. How many of you have used all related data source? Using all related data source. It's really powerful. So we're in effect doing a cross data source filter there. So that's another little trick that can be quite useful. How many of us use row-level security? We all do. I expect everyone's hands to come up. We need security. Row-level security is important. If you've implemented row-level security using create user filter from the server menu in Tableau Desktop, or if you've created a function, a calculated field using isMemberOf or username, one of the user functions, we immediately cause Tableau Server to not be able to reuse cache. That's just by design, because I can't use your query results if we've implemented row-level security. That's just by design. So while we need row-level security in many instances, just be aware of its impact on the potential performance scalability of our solution. A little word on filtering versus zooming. Maybe you use zooming on a map. Let's say we built a dashboard and there's a map in the dashboard that contains 1 million data points, and we publish that dashboard because we want people to be able to zoom in all over the country. When I zoom in to Las Vegas, for example, I'm not actually filtering the data out of the visualization. All I'm doing is changing the scope of the view portal. Those 1 million marks are still in the dashboard. If I was to filter alternatively, if I was to filter the data, I would have a much more lightweight dashboard running because I would only have the data for Nevada. So just be aware of the differences between filtering and zooming. Now, in terms of calculations, there's lots of different types of calculations. Row-level calculations and aggregate calculations, table calculations, LODs, and so forth. Be aware of where they evaluate. So The row-level calcs and aggregate calcs that we build in our calculated fields, they get pushed back to the data source. LODs, they get pushed back to the data source. I think I made an error in what I said. Table calcs are evaluated inside Tableau desktop or inside Tableau server. We don't want a table calc to be evaluated over 10 million rows because that's just going to take too long. So we would probably want to filter our data before we do that. If we're using external functions, R, MATLAB, Python, we need to understand that each one of the calls that we make are driven by the partitioning of our data. So if we've partitioned our data by customer name, for example, and we've got 10,000 customer names, we're going to make 10,000 serialized calls out to that service, which could obviously be expensive. So think about your implementation of those types of things. There are some physics involved here as well. Certain calculation types and certain operation types work faster than others. Operations on numbers are much faster than operations on dates and Boolean fields, which are much, much, much faster than operations on strings. The string functions, trim, right, left, mid, find, all of those, they're very expensive. A great alternative is the regular expressions. They are really fast by comparison. Things like minimum and maximum, well, how many of you use ATTR all over your dashboards, whether knowingly or otherwise? Yeah, you put a dimension on a shelf and you suddenly end up with ATTR dimension name. When you execute that dashboard or you render that dashboard, what we're doing is we're saying, if the minimum of my expression is equal to the maximum of my expression, then show me the expression, otherwise return a star. So that's a 3-step calculation. It's expensive. If you know that the domain of your data doesn't change across your partitions, don't use ATTR, change it to min or max. And that way you're only using one function as opposed to 3 calculations. Be aware of how big your data is if you're using LOD queries and the potential impacts of performance there. And understand, so this is a trick. So we build a parameter to select which type of measure we want to display on one chart. A lot of people use this trick. But the problem is we have to evaluate every one of these expressions before we can render the visualization. So this 3-part expression here causes this SQL to be run. We have to evaluate everything. We can't prune the decision tree until we've run all of these expressions. So in fact, here we're getting the sum of sales amount, the minimum of sales quantity, the count of sales of discount quantity, and the sum of discount quantity so that we can calculate the average of discount quality. We have to do this. Now, this might only be an issue if you've got something that looks like this, where there are some 30-odd expressions to evaluate based on the value of a parameter. This can be expensive. Using native analytical features like groups and bins and sets can be a lot more effective than your own conditional logic expressions. So if you're building KPIs by grouping things together, try and use the inbuilt functions rather than your own calculations. They can just be more optimal. Using case rather than multiple equality if expressions is going to be much more optimal. The case statement stops evaluating as soon as it finds a match, whereas multiple equality ifs just keep going. And simple things like an else if is faster than an else if, just because of the way it generates the resulting SQL query. Using regular expressions for strings. Be careful when you're using sets in conditions, logical conditions. They can be relatively expensive. And we need to worry about a thing called calculation explosion. Let me try and illustrate this. Here's a data set that contains only 1,000 rows. And the idea is we want to evaluate the percentage of rows in this data set that has an IP address versus the number of rows that have a proper domain name. That's that little bar chart down the bottom there. It's only 1,000 rows of text, but maybe we implement this using a calculated field that looks for and tries to parse out IP addresses. So we've got some logic in here that identifies an IP address. In this case, we're calling a particular function, address remove protocol and port. We're calling it something like 7 or 8 times in this particular segment. Then for the next segment, we're calling the same function 7 or 8 times. And we do it again for 3 and 2 and 1. So for every row, we're actually calling that same calculated field something like 100 times. And this, we're recursively calling things over and over and over and over again, and it becomes highly ineffective. And we keep going, and we end up with a really inefficient query. By contrast, We can use the same pattern, but replace all of that text parsing with a regular expression. And regular expressions are orders of magnitudes faster. So we do this, do this, do this, do this, do this, bang, 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 bang. And the results are the slow query with the text parsing took about 20 seconds. The regular expression took an order of magnitude less. That's the one at the top. So just be aware of the efficiency of your calculations. You might be introducing inefficiencies without even knowing it. How many of us use blending, data source blending? I would have thought more, but that's good. So blending is, you need to be careful with blending. Blending is designed to be used at an aggregate level, not at the row level. So my guidance is, don't blend on dimensions that have a very high cardinality. Credit card number, patient number, customer number. Don't blend at that level, because you're trying to do a join like a database server would. In other words, use blending at the aggregate level, not at the row level. There's little tricks like using primary groups and aliases. If all you're doing is using blending to get an attribute to stick on the end of each row, you can cause a primary group to be pushed into the primary data source. There's some stuff on Google to know how to do that. So there's a recap. There's a whole bunch of different things there in the analytics layer. So let's have a look at our data layer now. And I'm sort of accelerating because now we're in that area where we've got less control. Here we're introducing the data model itself, where we're creating our data model. Be aware that the connection types that we use, Oracle, Teradata, BigQuery, SQL Server, PostgreSQL, ODBC files, things like that, they each have different performance characteristics. No two connectors are the same in terms of their performance. ODBC tends to be really slow when you compare it to some of the native connector types that we've got. Data has, you've probably heard this, data has mass, data has gravity, data has inertia. When we need to move data around from one place to another to build a dashboard, we're incurring a cost in terms of time. So moving your data around by doing joining or blending in real time just incurs additional processing cost. You can influence this a little bit. Just recently we introduced some configuration of a cross-database join where we can tell Tableau, instead of bringing the data from all of the data sources into the Hyper Engine, take this smaller data source and move it over to the primary data source and do the calculation there. Rather than moving millions of rows everywhere, we can move a small set of rows to where the big set of rows are. Now there's some caveats around how this works, and I'm sure you'll be able to read up on that when you get to the web. How many of us use custom SQL? Yeah, everyone. IT says, here's the SQL you need to get to the data you need for your report. And you slavishly adhere to using that custom SQL for the rest of your life. What you want to do is realize that every time I touch a dashboard that's built on custom SQL, I re-evaluate that entire monolith of SQL code every time. And then I grab some data off of that and put it in my dashboard. You can make that process faster if you must adhere to custom SQL by running it as an extract. Push the custom SQL to an extract and run that, every night, for example, so that we're doing all of that monolithic code execution just once, and then we've got access to the extract, and we can do that much more rapidly. Or if you like, you can take your custom SQL and boil it down and extract a data model out of it. Here's an example of a custom SQL statement. It's kind of ugly. It's got lots of unions in it, and there's some conditional logic in there as well. You could boil that down and determine that, in fact, it all comes down to, when this custom SQL, this is a real use case, when this custom SQL was used in a customer's dashboard, it took about 5 minutes to load. And then every time they touched the thing, it would take 5 minutes to re-render. So you boil it all down, and you discover that, in fact, it's just grabbing data from 3 tables. So we can build that data model in Tableau's connection. And then there's some conditional logic that we can put into a couple of calculated fields, change that data source into the dashboard, and boom, 30 times faster to load. So there's some things you can do with custom SQL to make life a lot easier. The point about data here is that data that's stored for OLTP, operational data sources, is not necessarily shaped for analytical purposes. And so if you're doing a lot of reshaping of data, by reshaping the data model, doing unions, joins, pivots, calculations, splits, things like that, you're causing work to be done at analysis time, which means every time you touch your dashboard. Why not consider minimizing the amount of reshaping you have to do by changing the data model? Maybe use Tableau Prep, or maybe use some other way of changing the data at design time rather than at viz time. So move the logic back into the data wherever possible. I know you may not have control over this, but tuning your data source, your database, is vitally important. If you've got people running quick filters on all the dimensions in your tables and those dimensions are not indexed appropriately, then your queries will run really, really badly. So you can have a conversation with the people who own the data and say, my customers are using all these columns as filters, so we need these appropriately indexed. And the DBA might go, whew, okay, yeah, I hadn't realized that. The use of Tableau Server to implement governance models, so the people that know the data can shape the data sources to be highly optimized, and then you can set those up so that everyone can use them. I won't talk about this too much. I'm sure there have been sessions about using a multi-tier or multi-level data source strategy where you might have a highly aggregated data source to power one part of your dashboard, a medium-sized aggregated data source to power another part of your dashboard, and then the gazillions of rows in your Hadoop cluster to power another part of your dashboard. And you filter through and you drive your analytics that way. I've used that very effectively across multiple billion row data sources, and the dashboards perform really, really fast. Extracts, of course, can be a really good way of making your database seem faster than it really is, but don't just create an extract off of every row and column in the database. Hide the fields that are not necessarily going to be used for analytics, and then aggregate the data to an appropriate level. Maybe you don't need transaction level data. Maybe we're only interested in the data by day or by week. So you can hide unused field, aggregate the data, and then set up your extracts like that. Of course, Hyper keeps getting better and better. The most intriguing thing that happened in the last 12 months was the ability to use normalized extracts, that is, an extract with multiple table objects in it, and this solves some performance issues around user security. So there's lots of things we can do in the data layer. Finally, and there's just a few points to talk about here in the platform, and again, you probably don't have access to this. This is where we're concerned with the machines, the network, and Tableau Server's architecture itself. It's vitally important that someone in your organization monitor Tableau Server. Here we've got a tabmon output, and you can see that large blue chunk of data there, or whatever color it is, purple. That's a VizQL session that for some reason got stuck, and it just was hanging around, consuming memory, and thus preventing other resources from actually going ahead. At some point, the cluster controller identified that this VizQL was going rogue, killed it, and life was better again. But it's important to be monitoring what's going on your server to make sure that there aren't problems. It's a good idea to be testing your dashboard not only on the machine where you're authoring it, but also install Tableau Desktop on the machine where server is located and test it on that machine as well. That way you get rid of the potential network impact and you can diagnose faults like that. And just be mindful, if your dashboard is slow on desktop, just because you publish it to server won't make it faster. If it's slow on desktop, it will be slow on server. And again, this is something you don't necessarily have control over, but keep upgrading Tableau Server. It keeps getting better and better and faster and faster. Upgrade your environment too. I had a customer that had a test environment that was half as small as the production environment, but they were restoring from backups from the prod environment to do their tests before upgrades, and they found recently that it kept crashing. And they complained to me, my test server keeps crashing. Well, that's because it's only half as big as it should be. So you've got to make sure that your resources are up to speed. Anyone know this album? You gotta keep them separated. So consider isolating backgrounder processes from your VizQL processes. This is another great step you can take if you've got access to this level of control. And finally, in terms of a virtualized environment, do some research, do some homework, understand how virtualization works. Your VMware team will come back and say, oh yeah, we can run Tableau Server on the same server that we use for Oracle and 20 other applications. Tableau Server needs to be on its own VM, and it needs to turn off resource pooling, dedicated resources, because it's extremely latency sensitive. If the hypervisor is trying to dish out resources to multiple different clients, and Tableau Server is experiencing delays, some really funky stuff will start happening. So monitoring your environment, critically important, testing your workbooks on both environments, upgrading, isolating, and understanding virtualization. Whew. I'm a little bit over time, for which I apologize if you're trying to get to another session. So let's just summarize here. So many things to contemplate through the presentation layer, your analytics layer, your data layer, and the platform layer. You've got more control over how you build your visualization than you do how you build your environment. But you have to step through all of the things that can potentially cause problems and evaluate each of these ideas and think, is this going to work for me? There's no one size that fits everything. There have been a number of related sessions this week. It's too late to see them, although the session that Arlo and Wilson are doing, Vroom Vroom, performance tuning your dashboards, if you run, you can probably get to that session. Lovekesh's session on best practices for dashboard performance, he did it Wednesday and Thursday, an excellent presentation. If you missed it, wait for the video to come out on Netflix and watch it. It's a fantastic presentation. So with that, please let me know if you thought this presentation was useful. Go to the evaluations section on the app and let us know. I'd really like to present this session again next year, so give me a 10 out of 10. And with that, thank you.